So of course, we can't get through this without talking about what happens when things go wrong. We're going to talk about immunodeficiency and some of the classes of it. We're going to talk about what leads to allergies and autoimmune disorders and talk about some examples. So, immune deficiency, right? Basically, we're saying that something in the immune system, some sort of component, whether it be one of the proteins or a cell, right? Something in the immune system, some component in the immune system is deficient. It's either not there or it is not working, right? It's in too low in numbers or it's not functioning. So this means we have immune deficiency. This can be genetic or it can be acquired. So genetic, you're born with it. There is a problem in your genetic code that leads you to not be able to produce that protein, that cell, whatever, right, in a functioning way. Or secondary, acquired. This means you've caught something, right, that is going to lower your ability to mount an immune defense. So let's talk about some of the different ones. So if we have a T cell deficiency, right, we are not producing cytokines, we don't have them, or we don't have cytotoxic T cells like killing, or we don't have, we're not doing a very good job at killing both intracellular and extracellular pathogens. So if you have a T cell deficiency, right, you're not able to kind of moderate the immune response, and you're not able to get those cytotoxic T cells to kill off cells that are already infected and whatnot. And so this will put someone at risk. Any of these would put somebody at risk, but T cell deficiency specifically would put people at risk of gram-negative bacteria, viruses, and several fungi. With B cell deficiency, we're not producing antibodies. And so this is mainly going to hurt our ability to protect ourselves against extracellular microbes. So the encapsulated bacteria like Streptococcus, Haemophilus, Salmonella, Staphylococcus, some viruses, and enteric protozoans you'd be more likely to get, right? Or they'd be more problematic for that person. If you have a neutrophil deficiency, this is where you don't have that first responder. You don't get that phagocytic activity at the very beginning against extracellular microbes, and so we see some overlap with like Pseudomonas and Staphylococcus, as well as some fungi again. Complement deficiency is going to hurt your ability to also get rid of extracellular microbes. So again, we see that same list of encapsulated bacteria. And then asplenia, this is where we can't really clear the extracellular microbes from blood. And so same thing, encapsulated bacteria, we're at a higher risk. So you see, like, there's a handful of different ways things can go depending on which part of the immune system is affected. And so we see a lot of the problems, right, are going to come from microbes that are outside of the cells. T cell deficiency is where we're going to see the intracellular stuff really come into play, where that becomes more problematic. We also have what's called hypersensitivity reactions. These are basically where there's an overstimulation of the immune system, and we have a couple different categories. Type 1 allergic reactions, these are caused by allergens in the IgE. Remember, like, let's say you eat a food or something, right? You come into contact with something like a food allergen that it has that double binding, right, with the IgE, and then it triggers, the basophils and the mast cells to release things like histamine and cytokines. Type 2, this is cytotoxic. This is by IgG. Type 3 is caused by IgG and IgM, and type 4, this is called delayed hypersensitivity. This involves the helper T cells. So let's talk about type 1. This is an immediate reaction. Basically, remember that cross-linking of IgE, right, binding to 2 of the IgE antibodies or more. This is where we activate mast cells and basophils. And this is going to be immediate, right? So you're going to feel this immediately because you're releasing what we call vasoactive amines like histamine, serotonin, things that are going to basically like vasodilate, cause vascular permeability, and drop your blood pressure. This can be dangerous because it can cause anaphylaxis. Anaphylaxis, right? Somebody, they just came into contact with whatever their allergen is, so they've taken a medication or eaten a food that they're allergic to. Maybe they've been stung by a wasp or bee if they're allergic to those. And this is going to cause a life-threatening drop in blood pressure because that vasodilation has occurred to such a degree. It's actually going to start to block their airways. They constrict because of that vasodilation. There's fluid loss from blood, so they develop things like hives, their heart rate goes up, they have a hard time breathing, and then there's swelling that can happen, including like in the eyes, the lips, and the tongue. Very puffy kind of appearance. This is life-threatening. This needs to have medical attention. The common treatment for this is an EpiPen, so epinephrine, which will help vasoconstrict, so it'll help counteract a lot of these things. However, even if someone is given the EpiPen for this, they still need to go to like, it's still a problem. The EpiPen is only going to keep them alive long enough to get medical attention. So in the case of anaphylaxis, it's always a medical emergency. Even if they have like an EpiPen, they still need to get treatment. Hay fever, this is not as crazy of a response to pollen. So it's the immediate reaction to pollen. In type 2, 3, and 4, the immune system does not display self-tolerance. So in type 2 cytotoxic, this is IgG, is directed against a person's own blood cells or tissue. And so something like the type 2 reaction would be like if someone got the wrong blood type. This would be something that this could be something that happens if someone were, let's say they're type O and they get type A blood. It could trigger a type 2 reaction. Type 3 is also immediate. This is, again, where a person is attacking their own tissues with IgG or IgM antibodies, as well as the complement system. And so this is going to cause damage or inflammation to tissues like glomerular nephritis or lupus. And then type 4, this is a slower reaction. It usually takes 24 to 72 hours. This is where we have things like contact dermatitis, poison ivy, poison oak, nickel allergies. Basically, you don't immediately react. Something has been in contact long enough that your immune system goes, whoa, I don't know about this. I'm going to react. And so basically something has been, like, you've been exposed to it and you've continually been exposed. The cool thing, though, with some of these, like poison oak and poison ivy, which has this urushiol oil, that's what's triggering this reaction, is that specific compound, is that if you wash it off, right, really quickly, you can prevent yourself from having the reaction. So you can be exposed to it, but if you remove the allergen, if you remove the component fast enough, you actually don't experience the reaction because it's so delayed. So if you ever go hiking and you come into contact with something like poison oak, poison ivy, you want to wash it off quickly. And to wash it off, it means, like, I've had this actually happen to me personally. Dawn dish soap, plain blue Dawn dish soap, and a rough washcloth, and just really, you scrub the ever-living love out of that body part that came into contact. You just really go and wash it really, really, really well with that, and that usually is going to help. It's going to remove a lot of that component that will trigger the reaction. So I've saved myself, right? I came into contact with poison oak, and I actually saved myself from the pain and itchiness that comes from that exposure because I very quickly was able to get somewhere where I could wash it with that specific combination.